Tonight, we're going to take a journey that might change how you see everything. We're going to explore something that sounds simple, but is actually mind-bending. We're going to discover the true scale of our home galaxy, the Milky Way, and where it really sits in the cosmic order of things. Because here's what most people don't realize. The Milky Way is actually massive. It's one of the largest galaxies in the observable universe. But at the same time, when you zoom out far enough, it becomes almost nothing. And trust me, by the end of this, you're going to feel very different about that band of light you sometimes see stretching across the night sky. Before we start, if you enjoy these kinds of explorations, a quick like or subscribe would help keep this channel going. It's a small thing, but it means a lot. Now, let's begin. Let's start with what we know. You've probably heard that the Milky Way is big, and it is big. Actually, it's more than big, it's enormous. The Milky Way is one of the largest galaxies in the entire observable universe. Now, I know that might sound surprising, especially when you hear about giant galaxies out there. But here's the truth that most people don't realize. The vast majority of galaxies in the universe are actually tiny compared to the Milky Way. Most galaxies are dwarf galaxies, small collections of a few billion stars or less. The Milky Way, in comparison, is a giant. The Milky Way stretches about 100,000 light-years from one side to the other. That's a distance so enormous that light, which travels at about 186,000 miles per second, takes 100,000 years to cross it. Think about that for a moment. Light from one edge of our galaxy won't reach the other edge for 100,000 years. Inside this spiral structure, we have somewhere between 100 billion and 400 billion stars. The exact number is hard to pin down because, well, counting stars in a galaxy you're inside of is like trying to count all the trees in a forest while standing in the middle of it. You can see some clearly, but most are hidden behind others, obscured by dust and distance. Our Sun is just one of these stars. It sits about 26,000 light-years from the galactic center, tucked into a minor spiral arm called the Orion Spur. We're not at the center of anything special. We're in the suburbs of the galaxy, in a relatively quiet neighborhood where stars aren't too densely packed and supernova explosions are rare enough that life had a chance to develop and survive. The Milky Way has been our home for as long as humans have existed. Every star you can see with your naked eye on a clear night is part of our galaxy. Every constellation, every shooting star, every planet visible in the sky, all of it belongs to this one structure. For most of human history, we didn't even know there was anything beyond it. But here's where things get interesting. The Milky Way is genuinely large. In fact, about 95% of all galaxies in the universe are smaller than the Milky Way. When astronomers survey galaxies across the cosmos, most of what they find are small dwarf galaxies. The Milky Way is actually in the top 5% by size. That makes us exceptional, not average. Yet, despite being one of the largest galaxies around, when you start zooming out, when you start looking at larger and larger structures, the Milky Way begins to shrink in significance. Not in actual size, but in importance. It becomes one piece in structures so vast they dwarf even a large galaxy like ours. And that's the paradox we're going to explore tonight. How the Milky Way can be both enormous and tiny at the same time, depending on what scale you're looking at. But here's where things start to get interesting. The Milky Way isn't alone. It has neighbors, lots of them. The closest large galaxy to us is Andromeda, which sits about 2.5 million light-years away. Now, Andromeda is actually bigger than the Milky Way. It contains around 1 trillion stars, more than twice what we have. It's also on a collision course with us, but don't worry, that won't happen for another 4.5 billion years, and when it does, it'll be more of a merger than a crash. The distances between stars are so vast that actual collisions between stars are incredibly unlikely. Then there are the Magellanic Clouds, two smaller galaxies that orbit the Milky Way. The large Magellanic Cloud contains about 10 billion stars, and the small Magellanic Cloud has a few billion. They're visible from the southern hemisphere as fuzzy patches in the night sky, and they've been known to humans for thousands of years. But people didn't know they were separate galaxies until relatively recently. These galaxies, along with about 50 others, form what astronomers call the local group. It's basically our cosmic neighborhood. Most of the galaxies in the local group are small, dwarf galaxies with just a few billion stars or less. The Milky Way and Andromeda are the two dominant members, the big siblings in a family of smaller galaxies that orbit around them or float between them. The local group spans about 10 million light-years across. That sounds massive, and it is. But here's the thing that starts to put our galaxy in perspective. The local group is just one tiny cluster in a much, much larger structure. The local group is part of something called the Virgo supercluster. Now, a supercluster is exactly what it sounds like. It's a cluster of galaxy clusters. Instead of individual galaxies, we're now talking about groups of galaxies, all gravitationally bound together in an enormous structure. The Virgo supercluster contains at least 100 galaxy clusters and groups. One of the largest is the Virgo cluster itself, which sits about 54 million light-years from us and contains somewhere around 1,000 to 2,000 galaxies. Some of these galaxies are enormous, far bigger than the Milky Way. The Virgo supercluster as a whole contains about 100 trillion stars spread across about 110 million light-years. Let me put that in perspective. Remember how the Milky Way seemed big at 100,000 light-years across? The Virgo supercluster is 1,100 times wider. Our entire galaxy, with all its hundreds of billions of stars, is just a tiny speck in this larger structure. If the Virgo supercluster were the size of a city, the Milky Way would be smaller than a single house in that city. Actually, it would be more like a room in that house. But even this isn't the full picture, because in 2014, astronomers discovered something even bigger. They found that the Virgo supercluster itself is just a small part of an even more massive structure called Laniakea. The name comes from Hawaiian and means immeasurable heaven, which is fitting because Laniakea is almost incomprehensibly large. Laniakea is a supercluster of superclusters. It contains about 100,000 galaxies spread across 520 million light-years. All of these galaxies, including ours, are slowly moving toward the center of Laniakea, drawn by the combined gravity of all that mass. The Milky Way isn't just sitting still in space. We're falling, along with everything else in Laniakea, toward a region called the Great Attractor. Now, here's where the scale really starts to mess with your head. If you shrunk Laniakea down so that the Milky Way was the size of a grain of sand, Laniakea itself would be about as big as a large room. We've gone from thinking our galaxy is everything to realizing it's less than a speck of dust in a structure so large it defies easy comprehension. But we're not done, not even close. Laniakea is huge, but it's still just one supercluster among many. When we zoom out even further, we see that the universe is filled with these structures. Superclusters separated by vast voids, empty regions of space where very few galaxies exist. The universe, at the largest scales, looks like a cosmic web. Filaments of galaxies stretching across billions of light-years, connected by threads and separated by enormous empty spaces. The observable universe, the part of the universe we can actually see, is about 93 billion light-years across. Why 93 billion and not smaller, given that the universe is only about 13.8 billion years old? It's because the universe has been expanding. Light from distant galaxies has been traveling toward us for billions of years, but during that time, the space itself has been stretching, carrying those galaxies even farther away. Within this observable universe, astronomers estimate there are about 2 trillion galaxies. Let that sink in for a moment. 2 trillion. And the Milky Way is just one of them. Not a special one. Not a particularly large one. Just one among 2 trillion others. If we tried to represent this visually, if we made a scale model where every galaxy was represented by a single grain of sand, we would need enough sand to fill several Olympic-sized swimming pools. The Milky Way would be one grain in that vast collection, indistinguishable from all the others. Now, let's talk about the galaxies themselves in more detail, because understanding the full range of galaxy sizes is crucial to grasping where the Milky Way truly sits. And the key thing to remember is this. When most people hear about giant galaxies, they think those are the norm. They're not. Giant galaxies are the exception, not the rule. Let's start with IC 10101, one of the largest galaxies we've discovered. This galaxy is genuinely enormous. It's about 6 million light-years across. Remember, the Milky Way is 100,000 light-years across. IC 10101 is 60 times wider. If the Milky Way were a penny, IC 10101 would be a large pizza. IC 10101 contains about 100 trillion stars. That's roughly 250 times more stars than the Milky Way has. This single galaxy contains more stars than many entire galaxy clusters. It's so massive that if you replace the Milky Way with IC 10101, it would stretch far beyond our nearest neighboring galaxies. Andromeda, which sits 2.5 million light-years away, would actually be inside IC 10101's boundaries. But here's what you need to understand. IC 10101 is not normal, it's exceptional. It's one of the largest galaxies we've ever found. Galaxies like IC 10101 are incredibly rare. Out of the trillions of galaxies in the observable universe, only a tiny fraction are this large. Then there's NGC 6166, also known as the Medusa Merger. This galaxy is the result of 2 large spiral galaxies that collided billions of years ago. It's extremely elongated, stretching about 700,000 light-years from end to end. That's 7 times the width of the Milky Way. The collision that created it triggered massive bursts of star formation, and even now, billions of years later, the galaxy is still forming new stars at a rate far higher than the Milky Way. Again, impressive, but also rare. Most galaxies never undergo such dramatic mergers that create these elongated structures. The giant ellipticals are perhaps the most striking examples. A galaxy called A2261 BCG, which sits at the center of a galaxy cluster about 3 billion light-years away, is roughly 2 million light-years across. That's 20 times the width of the Milky Way. It contains about 10 trillion stars, all packed into a roughly spherical shape. This galaxy formed by cannibalizing other galaxies, consuming them over billions of years and growing larger and larger. These giant ellipticals are typically found at the centers of galaxy clusters, where their gravity has allowed them to consume many smaller galaxies over time. They're the kings of their neighborhoods, having grown fat by eating their neighbors. So yes, compared to these absolute monsters, the Milky Way is smaller, but let's put this in perspective. For every IC 10101 or A2261 BCG, there are thousands upon thousands of galaxies smaller than the Milky Way. The most common galaxies in the universe are dwarf galaxies. These contain anywhere from a few million to a few billion stars. They're typically just a few thousand light-years across, and they're everywhere. Absolutely everywhere. The local group, our cosmic neighborhood, contains about 50 known galaxies. The Milky Way and Andromeda are the two giants. Then there's Triangulum, a smaller spiral. And then there are dozens of dwarf galaxies. The Large Magellanic Cloud, the Small Magellanic Cloud, and dozens of tiny dwarf spheroidal galaxies that most people have never heard of. This pattern repeats across the universe. Every large galaxy is surrounded by dozens or hundreds of smaller satellite galaxies. The Andromeda Galaxy has its own collection of dwarf satellites. M87 has dozens of dwarf galaxies orbiting it. Wherever you find a large galaxy, you find many small ones. So when we talk about galaxy sizes, we have to be clear about what we're comparing. If we're comparing the Milky Way to the largest galaxies in the universe, then yes, it's smaller. But those largest galaxies are rare. They're the outliers. They're the exceptions. If we're comparing the Milky Way to the average galaxy, to the typical galaxy you'd encounter if you randomly selected one from the universe, then the Milky Way is huge, vastly larger, incomparably larger in many cases. The typical galaxy in the universe is a dwarf. It contains maybe 1 billion stars, maybe less. It's a few thousand light years across. It's faint, hard to see, and unremarkable. The Milky Way, with its hundreds of billions of stars and 100,000 light-year span, is exceptional by comparison. Think of it this way. If you gathered 1,000 random galaxies from across the universe, probably 950 of them would be smaller than the Milky Way. Maybe 40 would be roughly similar in size. And maybe 10 would be larger, with only 1 or 2 being dramatically larger, like IC 10101. The Milky Way is not in the top 1%, but it's comfortably in the top 5%. And that makes it large, genuinely large, by cosmic standards. It's worth taking a moment to talk about the different types of galaxies and where the Milky Way fits in this cosmic zoo. Astronomers classify galaxies into several main types: spirals, ellipticals, and irregulars. But within these categories, there's enormous variety, and understanding this variety helps us see just how the Milky Way truly measures up. Spiral galaxies, like the Milky Way, have flat disks with spiral arms extending from a central bulge. They're usually blue and full of young, hot stars, especially in their spiral arms. Spiral galaxies are still actively forming stars. They have plenty of gas and dust that can collapse to create new stars. The Milky Way forms about 1 or 2 new stars every year, which might not sound like much, but it adds up over millions of years. But not all spiral galaxies are the same size. Some spiral galaxies are much larger than the Milky Way. NGC 6309, for instance, is a spiral galaxy about 400,000 light-years across. That's 4 times the diameter of the Milky Way. It's sometimes called the box galaxy because from certain angles it looks rectangular rather than spiral. This galaxy sits about 52 million light-years away in the constellation Draco. Then there's Malin 1, discovered in 1986 by astronomer David Malin. This is what's called a giant low-surface brightness spiral galaxy. It's about 650,000 light-years across, making it more than 6 times wider than the Milky Way. The interesting thing about Malin 1 is that it's very faint. Even though it's huge and contains a lot of stars, those stars are spread out over such a large area that the galaxy is hard to see. It took until the mid-1980s to discover it, despite it being relatively nearby in cosmic terms. These giant spirals show us that while the Milky Way is large, there are still bigger spirals out there. But here's what's crucial to understand. These giant spirals are rare, very rare. For every galaxy